So this question says there's a point at 16 on the x, 4 on the y. So quick rough sketch somewhere over there. That's point P. And then point Q is going to keep changing. It's going to keep getting closer and closer to point P. Look, the x coordinates aren't off by very much, right? So the first point Q is 16.1. It might be a little bit above, a little bit below, but the point is, I guess no pun intended there, but the point is we're trying to get 2 points that are really, really close to one another. And then we're going to calculate the slope between them. So when WebAssign says they want the y coordinate here, all you have to do is plug in 16.1 in for x and figure out what it gives you for a y value. And in case it's been a while, this is function notation, right? You can think of f of x as like a y value. So we're plugging in 16.1 in for x. So to find out the y value that goes with that, we just have to take the square root of 16.1 here. So with our calculator, 16.1 square root. How many decimal values do they want? 7 decimal places. That's super. Okay, whoops. 1, 2, 3, 4, 5, 6. So that's the 7th decimal place. That's what I'm going to enter in WebAssign. And the point, I just want you to put it all together. 16.1 is the x, comma 4.0124805 for the y coordinate. And now for the slope, it's this, a secant slope is just the slope between 2 points. So you could start with either y coordinate. So I'm starting with point P, their y coordinate. I'm going to subtract that by Q's y coordinates. There's more there. I'll use my clipboard. And then since I started with P and the y coordinates, I got to start with P and the x coordinates. P has 16 for an x coordinate, and Q has 16.1. So if we're going to calculate, oh, there goes that notepad again. We're going to calculate the slope. 4 subtracted by that 4 with a bunch of decimal numbers after it. And then that goes up top. Then we're dividing that by 16 minus 16.1 gives us negative 0.1. So if you divide that by negative 0.1, negative divided by negative gives us a positive, and divided by 0.1 just increases by a power of 10. So there is meters per second. Now let me see, because where we round this answer, that's going to affect how many decimals we have here. But they say round your answers, so I imagine that's what they want us to do. Oh, man, that's tough. Let me go look. If I hit key, because that's only 6 decimal places. 1, 2, 3, 4, 5, 6, 7. That's fine. 1, 2, 3, 4, 5. Okay, so that's going to get students' answers marked wrong, which is a crazy reason to get your answer marked wrong. But when you calculate the slope, you got to use the non-cutoff decimal number. Okay, so this number up here I'm actually not going to use. I'm going to go back and redo this. 16.1, if I take the square root, there's our number without the decimal cutoff. And for WebAssign, unfortunately, we have to use the non-cutoff version or else it's going to mark it wrong. So we got to use, for this part over here, when we make our calculations, we got to use the longer decimal version. And then cut it off to 7 decimal places. 1, 2, 3, 4, 5, 6, 7. That's crazy. That's going to get some students that were marked wrong, and then they're going to start second guessing themselves. But yeah, so every answer, cut it off to 7 decimal places. But when you're making your calculations for your answers, you got to use every decimal value you get from your calculator. Make sure you don't lose anything. Okay, and that's the same thing for all these other ones. You're just getting x coordinates that are closer and closer. And that's the idea in calculus. Okay, is we're finding slopes at an instant. We're not finding a slope between 2 points. We're finding a slope between. We're finding a slope for just 1 point. Finding out how fast it's changing at that point. Use the values in the right column of the table to guess the value of the slope. They don't say what decimal value, but if you follow these the decimal values we have up here, they're getting really, really close, but never quite reaching 0.125. Right? So I guess that's what they're getting at here. Just making a guess since we're getting 99999, then we're assuming that eventually we should round up to 0.125. And then use the value from the question above to find the equation of the line at point P. So we guess 0.125, that's our slope, right? Okay, so our slope at an instant, the slope at exactly at point P is 0.125. And if you remember from fraction work before, that's 1/8, right? For your problem, you might get like 0.25. That means you got a fourth for a slope. I think WebAssign should be okay with either one, but we're finding the slope of a tangent line, which means, we got a curve. If we were to graph our original function, it might look something like that. And at point P, we're finding this equation of the straight line that touches at just one place at point P. Okay, so that straight line is going to have a slope of 0.125, or in other words, 1/8. We just need to know what the y-intercept is for that line. To find the y-intercept, you just do it like we did in algebra. You plug in 4 in for y, and then 16 in for x. And then if you simplify that, 1/8 times 16, that makes 2. Subtract 2 from both sides, and you get b equals 2. So our full equation is y equals 1/8 x plus 2. So if I type that in, I should accept this. And we'll type this in. It's not going to let me verify it, but I mean, this is perfectly acceptable. This is the same thing as what they have written over here. Either one should be okay.